Ladies and gentlemen, Mr. Cropper here. I'm wearing my hat all day, so I have hat hair. Just noticed that when I took my hat off, so I'll just leave it on. Screw it. We are going to talk a little bit about Stephen Wolfram. And why do I want to have a hangout? What's the question? Do you have any idea what the question is with Stephen Wolfram, or the problem? Or okay, let's talk about it for just a minute. Stephen Wolfram's book, A New Kind of Science, came out in like 2004 or something, and it was announced. I saw the announcement. It was announced in different places. They wanted to print 100,000 copies or whatever, and they ended up saying, well, we'll try 50, and then they reduced it to 40, or they said 60, reduced it to 50. Anyways, it was one of those things where they said, all right, we'll print it, but we'll only print this many. And then when the day of printing came, they said, well, we got to cut that number in half. I mean, they didn't think it would sell. All right, it was sold out. It just went like that. Now, I don't know why somebody didn't know that what he was saying was important, okay, in his book. We're going to talk about this for a minute, so settle in. He was saying something which, in this tiny, tiny, literally 25-word announcement in Newsweek magazine. You know, in Newsweek they announce 3 different books every week that have just come out, and his was announced probably in there. I mean, they didn't have any clue why it was important, or maybe somebody in there did, I don't know, but it was probably announced because of the phenomenon of it selling out immediately. I saw this 25-word blip, and I don't know if they understood exactly what they said, but they got a brilliant sentence somewhere. And the sentence said, Stephen Wolfram's book, A New Kind of Science, which predicts... What was it? I don't even know. That order arises from simple rules, and that... I don't know. I can't even remember the sentence. It was so brilliant, and it was so short, and I went, wow. And it clicked for me, and I said, I've got to get that book from that little 25-word blip. But, and here we are, we're shifting gears. Put that in your pocket. What question did I have in my mind that when I was skimming over the Newsweek that day, that hit home for me? I had some question, and when I heard the basic thesis of his book, it snapped 50 cogs in my mind. What was my question? And the best way for me to articulate what my question at the time was what is going on with the second law of thermodynamics? It says that disorder tends to increase over time in systems in general, in our universe, period. So that doesn't mean it always decreases over time. Sometimes it increases, but over time it decreases. Now, the ultimate, for those of you who aren't totally physics oriented, but you want to sort of start wrapping your brain around these kinds of things, let me give you an idea of what it means for order versus non-order. Early in the universe, and I assume the Big Bang, and I know the Big Bang is full of holes and there are lots of problems, but we may be able to explain our way out of the redshift thing. I don't know. I do have ideas on an evolving universe, and I think that that's what's indicated by Wolfram's work. So let's talk about that. In the early stage of the universe, there were unstable molecules or particles or something, and it was expanding. Now we have to assume the Big Bang. All right, going forward with the Big Bang and assuming that if we do explain our way out of the Big Bang, it's going to be something that's going to fit within the parameters of still allowing the redshift. It might even still allow movement. That it may be the case that those things really are moving away and the redshift isn't caused by some other phenomenon, slowing down by going through clouds of dark matter. What would the dark matter be? That's a different question. But let me just hint to you, because I am going to do videos on this someday. The dark matter would be bits of the universe that were out of the way where regular matter started and just never got incorporated, and then they've gotten wrapped around each other with gravity fields or whatever and have never touched. But whenever they touch, boom, there's a problem. But they've just never touched. Now, these things happen. There are corners of the planet, like look at Earth. You'd say, well, it's so old that all of the continents have been churning and all this. No, look at Australia. Australia's just been floating over there. Nothing's bothered it. It hasn't bumped into anything or been taken over or gotten sucked down under a plate. There are little bits and pieces here and there. Here's what would happen in the early universe after the Big Bang. There would be particles here and there that did their thing, like little lions and tigers. But they might not eat up all of the other little things. So most of the universe is lions and tigers, but they didn't get all the way. And before they were able to get all the way, everything got wrapped around up under these other phenomena. We call these other phenomena black holes, gravity, whatever. So over time you have bits of the universe that have evolved in one way and bits that have evolved in the other. And if the one bit touches the other, that other bit goes away. And everything changes, and I don't know if there's energy or a unicorn pops out, but if those bits meet, problem. So our universe is made of 2 bits, or maybe, crazy idea, 3, 4, 5, 7, 9 bits that have never met. But the 2 bits that I can think of and have any reason to believe in are regular matter and some sort of really strange heavy or dark matter. That all can be thrown out the window if you think that electricity rules, and electricity causes the rotation of the galaxies. But the question is, at the end of the day, and all this fascinating stuff, is why, if disorder increases over time, why could it increase? And not only that, because that's just getting started. All you've done is taken a cloud of dust and gas where you couldn't tell where any given atom was going to be at a given time because there was so much chaos in the cloud, and you put them all into a star, collapse them through gravity, and now you might not know exactly where the atom is, but you can sure tell a lot better than you used to could. It's within a certain sphere of area. It's much more predictable. You can know a lot more about when it will be, where it will be, how long it will be there if it gets into these systems. So those are orderly. Those aren't even interesting. Not even interesting. Beneath the notice of philosophers. What's interesting is life. How does life occur? What's the excuse for that? So how can order come from chaos? And Stephen Wolfram answers that brilliantly. Brilliantly. So, go watch everything you can about him. Get his book if you can. The Hangout's coming up. It's scheduled for Monday night, June 20th, starting around 6 p.m. Eastern Standard Time, between 5 and 9 p.m., depending on, if I forget to get beer, I'll have to go out and get beer before it starts. All right, I hope to see you there.